Thank you very much for the introduction. My name is Sofia Hiorth of Ornäs. I work for Sweet Technologies. I am a project manager in the fiber modification area. During this speak, I will briefly introduce Sweet to all of you if you haven't heard about us before. Then talk a bit about the different materials we develop within the company. Sweet Technologies today have 26 full-time employees divided onto 32 persons, which means we have a few consultants working for us as well. The company has 3 different research sites. The headquarters is in Umeå. We have an office and labs in Uppsala, and the fiber modification group is based here at KDH, Alba KDH, on floor 2 of this building. The owners of Sweet are listed here. Woodheads is one of the biggest owners. I actually think it's the biggest owner. And Innovationsbron, the Kempe Foundation, and a few forest companies in Sweden. Sweet work in a range of different application areas. In Umeå, they are focused on breeding, seedling growth and vigor, cloning and forestry and transgenic trees, where fiber modification is here. I should say that the cloning and forestry has sort of a headquarter in Uppsala. I will focus on the fiber modification part of Sweet, but I just want to mention that in the area of seedling growth and vigor, we have launched the first product. It was launched last year. It's called Argrow. It's a fertilizer based on the amino acid arginine. It helps the plant to develop in a much better way. It has tremendous root system, which make the survival rate enormously improved. Another good thing about that is that the leakage of nitrogen to nearby lakes and so on is significantly reduced. Sweet as a company has a sort of unusual setup. Woodheads is a company owned by 46 top scientists in Sweden, working in a lot of different fields, all the way from gene modification to material science. These scientists belong to different universities all over Sweden. SLU, which is the University of Agriculture, Umeå University, Uppsala University, Stockholm's University, as well as KDH. There are a few research centers where these researchers are involved. These include UPSC, which is the Umeå Plant Science Center, Bioinspired, which you have heard about earlier today, as well as the Wallenberg Wood Science Center, which is the newly launched center that Lars Berglund presented. For the fiber modification area, the researchers are mainly at KDH and involved in Bioinspired and Wallenberg Wood Science Center. And to Sweet, this group of researchers are tremendously valuable. Since they are owners of the company, and also that we in Sweden have something called the teachers exempt, which means the researchers, they own their own innovations. They can do whatever they want with their innovations. And these researchers, as owners of Sweet have given us the rights to their inventions. These innovations feeds into Sweet, and we apply them all the way during the development of from the plant all the way to the final product. Because these researchers in Woodheads, they are a great expertise to us. They cover a lot of different areas. So even though Sweet is a rather small company, we have one of the largest research departments. Our business idea is to realize the value of our knowledge and to commercialize these innovative products that might be developed from these innovations. We do this both through exclusive collaborations with industrial partners, as well as develop products our own. The fiber modification area of SweetTree was initially based on patents around the set technology. Today, the fiber modification area has 6 patent families, and new areas are continuously emerging. Now I'm going to just briefly let you know a bit about these different platforms. We have super hydrophobic surfaces, which I will tell you more about, as well as magnetic cellulose and modified xyloglucan. We also have heard a bit from Lars Berglund and Vincent Boulon about the strong nanopaper. We also have platforms for cellulose spheres and direct modification of cellulose. The 3 at the bottom I will not talk more about today. The top 3 I will go into a bit more detail around. I'm not sure if you saw the poster presented by SweetTree at Coffee. If you didn't, you are welcome to have a look during the mingle time. We show prototypes of super hydrophobic surfaces and magnetic cellulose. I will start with the super hydrophobic surfaces. I'm not sure if you are all familiar with this type of expression. I know you have heard it several times today. If a surface is hydrophilic, a water drop spreads easily on the surface. If it's hydrophobic, the drop is not liking the surface very much. But then there is another stage, which is called the super hydrophobic surface. And that is when you put a drop of water on a super hydrophobic surface and you tilt the surface. If the drop rolls off, it's a super hydrophobic surface. And this has many advantages.